All right, welcome back. We are GAME3001 in the summer 2020 semester, and it's week 9, part 2. We're going to do our lab today, and we're going to do work on some part of the of assignment number 3 is what we're working on today. And specifically, we're going to work on the debug views and whatever else we can get done before the end of today. So let's take a look at what I'm asking you to do first of all. So I'm going to go to here. If you go up online, there is a Lab 9 starter that's up on Blackboard. So Blackboard has this Lab 9 starter. And there's a Lab 9 Dropbox. This is where you're going to submit your GitHub link. So again, the only way you can get marks for this one, I will not accept a zip file. The only way you can get marks for this one is if you submit a GitHub link, which means you need to have GitHub in order. It means you have to have a GitHub account. That's an important part. And you need to know how to do GitHub alongside of Visual Studio. So that's what's happening today. That's how you're going to submit. So just looking at our collection of students in this afternoon, of the 3 of you that I have, are you all good with GitHub, your GitHub account? If you are, check mark. If you're not, X, please. Oliver's good. Check mark, please. If you go to the participant panel and click check mark or X, because I'm not going to look at the thing. Thank you. Juan's good. Paul, go click the check mark on your participant panel. Click on participant and go there and check. Hey, that's good. Okay, good. So we're good. So all of you are good with GitHub account. That's awesome. So please download this starter zip file right here. I'm going to do the same thing. So you're going to notice a bit of a problem, and sometimes it happens. I'm going to click this, and it's going to attempt to download the GitHub link here, right? Notice. And then as soon as I'm done downloading, it's going to give me an error, right? As an example. And it does this because there's an executable inside of the zip file. So Chrome says, hey, there's a problem. Now I've already done this, so I've kind of accepted that I'm going to get this thing. It's in my downloads folder. You're going to have an error. You're going to have an error potentially that says this is a dangerous file or something like that. To avoid that, you want to press Control and J in Chrome, which is going to bring up the downloads. And what you want to do here is when you download it, you're going to say keep. All right, so you're going to go through here and you're going to accept it. Now I've already done it, and that's why it's allowing me. Let's see if I can do it, if I can emulate this again. So maybe I have to refresh the screen. And maybe I have to go back and forward or something crazy, like go here and I don't know. I don't think it's going to matter because I've already done this today. So I've accepted it. But I think if you don't accept, then it's not going to matter. So if I go here and download, as an example, it should download really quickly. And then last time what I got, and a lot of people got, was an error, right? And if you get that error, you press Control and J, and it's going to bring you to downloads. So Control J. You can even do it now to watch the download coming, right? And in my case, it just worked. Your case, you're going to see that it's going to give you a bit of a problem. I'd say it's a dangerous file. Do you want to keep it, or do you want to do? And then you say you're going to keep it. You don't discard it. If you discard it, you won't get this file. So that's number 1. So do you guys have the file? That's a check or an X. So hopefully you guys got a check. Oliver, still waiting on you. I'm just going to grab this. Thank you, Oliver. Okay, that's good. I'm going to clear all those. And I'm going to go to my desktop where I'm going to put the file. So here's the file on my desktop. It's starter lab 9. Okay, I'm going to unzip it. Now this is another thing people had problems with today. I'm going to unzip this. I'm using 7-zip, and some people are using Windows to send to. as an example, or they're opening it up with File Explorer or something like that, you'll get mixed results. So my recommendation, if you haven't got this already, is go to download 7-zip. So go to 7zip.org/download.html. Download your 64-bit version of 7-zip, and then you'll have an option. If I right-click, I can go to 7-zip, and then I can extract to the file name. All right, extract to GAME3001 M2020 Lab 9 starter. Okay, so it's going to take a second to do, a few minutes, or maybe a minute, not even. And I've got this. Now, for your lab, you can leave it like this. If you want to leave it lab 9 starter, because I didn't mention anything to the gang in the first half, the first section. But if you want, you can always change this to lab 9, right? Which is what I'm going to do. Okay, so there's lab 9. Okay, let's get in there now. So if I go to lab 9, I'm going to pull up my solution. I'm going to double click on my SLN file, and it's going to bring me Visual Studio 2019. And you're going to see this error come up. And the reason for this is because I've left some of these documents open, and it's looking at my file path. It's unknown. So the best way to get rid of this thing, just ignore this, but just right click on one of the documents here and just close all documents. And then if you open up your solution, that's a weird error, by the way. If you open up your solution, you'll still see all the files. This is a good thing, right? And what we want to do is we want to retarget your solution. So I'm going to right click on my solution, and I'm going to click Retarget Solution. It's going to choose the latest SDK as an example, right? That's on my system. And you'll do the same thing for your system. Your system and my system will have potentially different versions of the Windows SDK installed, and you want to retarget your solution so it matches that. Okay, so that's the second one. And then what I want to do is I want to run this thing so to see if I get the same files we had from last day. So we're just going to just click on the run button up here for locals window debugger, and we should get, after it builds, everything running. And what I'm going to ask you, of course, after this is please put a check mark when your system has run the scene and you get the basic scene. If you can't do it somehow, or if it's broken, doesn't work for you, well, Oliver, you're faster than me, then you should be able to do it. If not, put an X if somehow it gives you an error. Awesome, you guys are faster than I am for running. Okay, so remember last day what we did? We did one of these, and we have this little guy running around, and we're showing the line of sight line, which is kind of really boring. And what we want to do is we're going to turn this off this time around with some debug keys. And why? Because if you notice down in here in the assignment document, right, that's the thing you're going to do. One is 5 points for setting up your scene. You can do that. I mean, I already have 2 labels, and I recommend you if you haven't started assignment number 3, you should start, because this is you're not going to have a lot of time. In the place scene, we've got some movement. I can't do all of it for you, but we have some movement, and with an actor sprite. And one of the requirements that's inside down here, it says we need to set up a debug view. And the debug view is you're going to get an H key, and there's some debug keys. We're going to start with this, see how far we get. And if we can, we'll add in some additional things for the actor sprite, so the actor sprite can move around properly. If you already have this as an example, that's okay. But if you don't, then I'm going to try and get you guys going. I want to get you some points, get going on some of these requirements, because look, the debug view, if you get it all going, is almost worth as much as animations and base enemy animations and sound effects combined, right? So it's worthwhile doing. All right, so let's get this going. So the first thing we do before any of this is put this up on GitHub. So the way it works with Visual Studio is I'm going to go to Team Explorer. If you don't have the Team Explorer view here, you're going to go to View, the View menu, and you're going to go to Team Explorer. So there's Team Explorer. It's going to take you to this view, all right? Or maybe something else. What you want to do is you want to go to Home. Click the Home button, and then it'll take you to this view for sure. And then you're going to go to Changes. You should see all of these changes, right? Or some other changes. And what these changes are project settings changes, because we retargeted our solution, we generated an executable file, and some other hidden stuff in the template folder. So that's what these are. I'm going to add a new commit message, and it's going to say updated project settings. I'd like you to do the same thing, please. Updated project settings. And then press commit all. Okay, so that makes the little commit message here. And notice there's a little commit. You're going to get a different commit number than me. Cool, we've done our first commit, but now we got to put it up on GitHub. In order for us to do this, I'm going to go to Home now, Sync, and because I've disconnected it from my GitHub repo, you're going to see these three options. Okay, first of all, if you don't see these three options, and maybe some of you don't, especially some of the people online who are watching this, you need to go to Extensions, Manage Extensions, and under the Manage Extensions tab, you want to look for GitHub extension for Visual Studio. All right, that's the one you want to search for. You can actually search for it up here in the search bar. If I type in just the word Git, then it's going to filter and it's going to provide anything that has Git in it. This is the one we want. It'll have a download button that looks like this. Click it and download it, but you won't be able to install it while Visual Studio is running. So it's going to ask you to reboot your Visual Studio, and then it's going to do the installation. Once it does, you're going to have, when you come back to Team Explorer and Home and Sync, you're going to have this GitHub option. Now, for the three of you that are on, do you guys all have this GitHub option on your Visual Studio? Yay, that's awesome. The first group did not. Some of them did not anyway. All right, so before we actually click this Publish to GitHub link, we're not going to do it yet. I want to go to Home, and I'm going to go to Settings, and I want you guys to check that in your global settings, you have your username, which as it appears on GitHub, and the email address that appears on GitHub. Okay, so these are the two things you need to set up your credentials, right? If you've got this, check mark, please. If you don't, X. Like it'll be your name here, not mine. So this is on Home, Settings. And if you don't, fix it until you do. And you should have, so again, it's under Home. If you go to Home and if you go to Settings, that's what that is. Okay, and if you go to Global Settings, and then you'll see where that is. You can put in your name and stuff in there. Okay, so I'm assuming 2 out of 3 of you have it. I'm hoping that you're able to do this. And there we go, thank you. Okay, and now I'm going to go to Home. I'm going to go to Sync. I'm going to click on Publish to GitHub. All right, and under Publish to GitHub, you're going to select your account. I'm going to select my account. I'm going to make mine private. You're going to leave yours unchecked. Please don't make yours private because you're going to submit something to me that I have to have access to. All right, so please leave yours unchecked. Me, I'm going to make mine private, so you have to use your own. Okay, not mine. Because in the past, what people have done is they just copied mine and then they submitted it, and that's not the exercise here. So don't check this for you. All right, and then press Publish. What it's going to do, if everything is good, it may ask you to log in for the first time. It might say log in with your credentials. And if it does, as long as you put in the proper username and password, then it will create the remote repository on GitHub. And if I go up online now, you should be able to see your repository on GitHub. So if you just type in github.com, and if you go to your repository, if you go to your repositories, then you should see the new repository you just made. Now mine is private, yours should be public. Yours should not have anything here. It should be like one of these. Okay? So that's what it should look like. And if you click onto it, you'll see this. Under commits, which is over here, right? So you have now you have your repository. And under commits, which is right over here, if you click on commits, you should see 3 of my commits: add project files, added line of sight check, added right and left movement, and updated project settings will be yours. This will be your commit up here. Are you with me? Do you have these 4 commits or something like that on GitHub? I'm going slow here because remember that you're going to submit this stuff to me later. So make sure you have these commits here. Okay, so I got 2 out of 3. Yay! Okay, awesome. So that means you guys are on track for doing this better than the first class. But then there's only 3 of you. The first class had 20. All right, so cool. So good, we're on the same page. We've got this. We've made this template. We've got it on GitHub. You're almost there to submit what you have already. Just this alone is good, because in previous classes I had half the class not submit because they don't know how to do GitHub. All right, cool. So we're good. We're going to go to my Solution Explorer now, and then we're going to start hitting off some of those requirements. So again, let's take a look at this. What I said was I need a debug view, right? I need a debug view to work. And in order for me to have an H key work, let's explore the event manager a little bit. So if I go to managers, and if I go to event manager.h, you can see that the event manager.h file, when it opens, has the following public methods or functions, if you will. Pub update and clean. These are the lifecycle functions for this manager. Then you have is key down and is key up, and some mouse events, as well as game controller events. So you have keyboard, mouse, and game controller support out of the box for our little project files. Okay, that's the thing. So we want to do an is key down to scan for the key, which is the H key. That's what we want to do. We're not going to do it here. We're going to do it inside of our scenes. If you go to scenes, and if you go to playscene.cpp, right? We want to do it inside of our play scene. And if you notice, there's a handle events function. Inside of our handle events function, we have an event where the number of joysticks is greater than 0. So that means that we're using a game controller. That's what that is. You don't want to put it in here. And there's an event where the number of joysticks is less than 1. You could certainly put it in here, but this is really for player movement. All right. We don't care how many joysticks there are. If there's 1 or if there's 10, we want it so that way it won't support 10. It'll support 4 or something like that. What we want is anytime anyone presses anything, we want support. And there's an example of it further down in the handle events function. There's a is key down for the escape key. So let's try this out, and let's code it in. So we're going to say that if event manager instance is key down for the SDL scan code, and we want to choose something, but I want to change this to H, SDL scan code H. If this is key down, then we're going to get input, right? Is key down. What I want to do is when I press the key down, I want to toggle between debug mode and no debug mode, except we don't have a debug mode flag, which we're going to create now. So we're going to go back to playscene.h, and under playscene.h, we're going to go into the private area of the class, right? And we're going to make a brand new Boolean called m_b debug mode. Okay? m_b debug mode. M private member variable, b Boolean debug mode in the identifier name. Okay? Debug mode is something we should probably initialize to to false just to be explicit. So I'm going to go to playscene.cpp now, and I'm going to jump to, in the jump menu, the pull down, I'm going to jump to start. And under start, just on the top there, I'm going to say that m_b debug mode is equal to false. And what this is going to say is, by default, there's no debug mode. You're not in debug mode. And to fix up an initial toggle, what we want to do is we want to go into isKeyDown and say that m_b debug mode is equal to not m_b debug mode. And what this does, of course, is it flip-flops. If it's false, it's now true. If it's true, now it's false. So this is the toggle. So again, this, just as a comment perspective, toggles debug mode. That's what this does, right? However, this isn't going to work yet. We want to make it so when debug mode is toggled on, then I can see my my debug drawings, and when debug mode is toggled off, they're not drawn. And to do this, this is the mechanism for turning it on and off. But to do it, we need to jump back into the draw menu, and under the draw menu, where it says draw line, I'm just going to give us some more real estate here so you can see it. In the draw line, we can say is if m_b debug mode, if that's true, then what I want to do is draw the line. But if it's false, then I don't want to draw it. That's what this is. So this happens in debug mode. So if debug mode is true, draw it. If it's not, don't draw it. But we're going to have a problem. And welcome, Nestor. I know you were running a little late. We're just inside the lab portion. Worst case, you're going to have to either watch or watch the video after. All right, so how does this work? Let's try it. So that's the next part. So we're going to try it. And let's see what happens. My expectation is it's going to work kind of, but kind of not. And we're going to see what happens here when it does. So as we launch, you can see we've got our window, and we're automatically colliding with no line of sight. If I press H, then I get this thing that shows up, but then it kind of doesn't. It's kind of flaky. And why is that? Well, to explain the flakiness of this whole thing, we have to go into a little bit more detail. I'm just going to turn off the line of sight detection right now. So I'm going to go to Solution Explorer. I'm going to go into my collision manager.cpp, and I'm going to go down to, I'm going to jump, I'm going to use the jump menu here. So the global scope is going to go collision manager, and I'm going to go from there we're down to where it says line of sight check. That's the event that or the function that I want to jump to. And if I go down there, you can see that I have this little cout statement. I'm just going to comment it out for now. It's still going to return false if we have no line of sight, as an example, but it won't print this out anymore. Instead, what I want to do, I want to go back to the playscene.cpp, and where I put my debug mode switching on and off, which is down in here in my handle events function. So when I turn debug mode on and off, I want to, what I want to do is I want to show a little message. I'm going to say if m_b debug mode, right? If it's on, then I want to say std cout debug mode on, right? So we'll say debug mode on. Okay. Else, I know it's kind of a useless else, but let's do it. Else, if debug mode is off, we're just going to say debug mode off. Okay, and we're going to see the effects of this. Okay. Debug mode on, debug mode off. Pretty simple. And it all depends on this. Now, there's some ways of optimizing, and we'll do that later. But for now, let's just start with this. So when I run it now, let me go to here, and I don't get any feedback from this guy, but if I press H, now we start seeing what's happening. I press it once and I get all these things. Why is that? How come I got all these things like this? I pressed it once, look, once, and I get like toggling happen like crazy. Can anyone tell me what's going on? Any one of you guys? Why is this happening? Why is it when I press the H button once, I'm getting like on, off, on, off, on, off, on, off? Why is it happening? Guys, this is a key thing to make your keys work properly. I'm not seeing any response. And the next question I have for you, well, is accounting for a key held? Correct. But that is exactly what's happening, Oliver. It's what's happening is as I'm holding down the H key, so too is the debug mode turning on and off. It'll keep turning on and off forever as long as I hold down the H key. I don't want that functionality. I want to touch it once, and then it's going to go on or off. And it's going to be more sensitive than what it is right now. So which means that I don't want constant feedback from my H key. I only want it happening once in a while. Unfortunately, in my event manager, it doesn't allow that. It doesn't sit there and say, is key down once. I don't have a function for that, right? Maybe what I can do is later on, but not now, I can put in another value where I can say something like constant polling, or maybe another event which is key pressed. Is key pressed, which is a different thing than is key down. Key pressed and key down is different than key down and key up, right? It's different. But that's not what we have right now. I don't want to monkey with my event manager. I just want to do it in my play scene. So in order for me to accomplish this, I need to be able to track that the key down, that the H key has been pressed already. Okay? So a couple ways we can do this. We can do it through a scan code, which is tough, or we can do it through my play scene. Let's do it through my play scene. So I'm going to create a new Boolean, another flag, and it's going to be M_B, and we'll say the H key pressed. H pressed is what we're going to call it. H pressed. Okay? Not a great name, but who cares? Right? And H pressed, by default starts off as false, but let's be explicit. Let's go to the playscene.cpp, and we'll go all the way down to the start menu again, start method. And underneath this, we'll say that, our H pressed is going to start off as false. Okay? We don't have to do this because by default they're false, but we'll do it for completeness. And you know what? I want to say something like this. The only time that I want to listen from my scan code H is if this is false. If this is true, if I'm already pressing the H key, I don't want to listen to my presses. So what that means is if not M_B H pressed, if it's not pressed already, then I want to listen for it being pressed. Okay? And if it's pressed, if I just started to press it, I want to say that M_B H pressed is equal to true. Now it's not false anymore, it's true, which means it'll skip this the next time. But I need a way of resetting this when I'm not pressing this, and of course we have the is key up event. So we're going to take this whole thing, and I'm going to make a new if statement. If event manager instance is key up for the same key, we're listening for the same key to be up, right? Then and only then do we want to set that M_B H pressed, which is the H key being pressed, to false. Now you're going to say, wait, Tom, there's a better way to do this. And you're right, there is. There is a better way. But I'm not modifying my event manager right now. I'm just adding this into our play scene to make sure that it works. All right, let's try this out and see if this does what I'm supposed to do. So I'm going to click play. And under my play button, we should run again. I'm waiting for it to run because my machine is doing a lot of things at once. Here we are. And if I press the H key now, it turns on nicely and turns off. Turns on, turns off, and it's solid. It's like I have to, if I hold it, nothing happens, right? But if I press it a bunch of times, it can turn on and off at will. Are you with me? Check mark if you're with me, X if you're not. Again, for those people who are with me, like physically watching. Okay, thank you guys. So that's great. So now think about this. This is kind of pretty verbose, right? I mean, it's like, hey, we got to do this, and then we got to print this out and so on. But it serves a purpose. It kind of satisfies my requirements. And could you do it different ways? For example, in the event manager.h, there is this is key down event, and there is something called an array of key states, m_key states array, right? So this key states array, right, it starts off as nothing, right? It's the only time key states get added, right, at all. Notice that right now we have a reset, we have an update and clean, and is key down, and so on, and an event manager constructor. If you go to the constructor for the event manager, just for a second, you can see that the event manager construction says, let's make key states initialized to null pointer initially. Okay, so all key states are null pointer, they're nothing, right? And we initialize mouse wheel and is active if this whole thing is active at all. If you want to get in input, right, as an example. And it says initialize button states for the mouse. So we initialize all the button states for the mouse. And we initialize our controllers, but we never initialize key states, right? So how does this work then? If we never initialize key states, how does it keep track of the key state at all? Well, if I scroll up to where we start listening for key states, and I'm talking about on key down and on key up, it says that key states is equal to SDL get keyboard state. That's what it does. On key down, null pointer. Okay. Now these, right, are internal. These are private. Okay. So this on key down and on key up. Okay. And you can see that because if I go to the event manager.h, right, there is this, on key down and on key up here. These are private member functions right here. These just handle keyboard events, right? But there's also is key down and is key up. Is key down actually scans for a specific key to be up and down. Okay? So go back, you can see that I initialize SDL keyboard state, and I when this thing happens, what it says is an array, it returns an array of key states. Indexes into this array are obtained by using SDL scan code values. So on key down actually kind of initialize key states for on key down and on key up. But these things get modified somewhere, right? And if you look at the update function, right, update, we check to see if it's active, right? And then we listen for game controller input. We also listen for different kinds of events. So when the event is going on, we're listening for SDL key down, we're listening for on key down, and SDL key up events generate the on key up function. So depending on if a key is being pressed, it generates those functions. That means it starts polling, it starts listening, right, for a specific key. And the key changes every single time. So the array of keys that it adds, right, as an example, or changes the state for, has to be initially kind of, you have to have a key down event in order for you to do a key up listen event. These two things, this won't fire. A key up event won't trigger unless there's an initial key down. That's the way it works. So making use, the reason why I'm telling you this, you might think that, well, we can probably use the built-in is key down and key up event, this stuff up here. Is key down, is key up, right? We can listen for the H key and whatever. And yeah, the problem with this is if you start listening to is key up and there's never been an is key down, this is going to turn out to be false every single time, right? So that's why it won't work. That's why we're using an extra flag right now. Again, what we need instead of this, right, is another event, another keyboard event called is key pressed, which is with a scan code, but it's only going to work once. It's going to keep track of if the key has already been pressed, and it's only going to respond once, as opposed to always, which is key down. That's a different event. Okay. But we've handled it here. We've done it here in our playscene.cpp. Okay? And we've taken care of this first requirement. So if you look at the requirements here under the assignment, it says, hey, when a user presses the H key, your program will toggle into debug view. It does that. And only does it for line of sight, though. It doesn't do it for detection radius. That's on you. And we haven't done collider boundaries, which we'll do shortly. Okay? So that's what it does. Let's do collider boundaries next, and we'll have the most that we can for debug view. We'll put it up on GitHub. So I'm doing it in a different order than I did this morning, or this early afternoon. I'm going to do debug keys next. All right, so collider boundaries. That's interesting. So collider boundaries, anytime anything being drawn is in here in the draw function, right? And what I want to do is I want to show my collider boundaries. And the way to show my collider boundaries is if I'm going to draw a rectangle around my player, my plane sprite, and my obstacle. I'm going to draw a rectangle around them, assuming that we're going to use AABB type collision detection for them. If I use another collider shape, like for example a circle-circle collider or a circle AAB, we have to draw different things here. Okay, but I'm assuming you're going to use all AABB style collision detection, which will suffice for this assignment. So again, we're going to say util DrawRect instead of draw a circle or line, and it's asking for the position of the thing that we want to draw, width and height, and a color. We don't care about the color, we can leave it at green, but position, width, and height is what we need. So position is, let's say start with the player position. We'll grab this. And then width and height. So m_p player. And then we want to get width. And m_p player get height. Okay, so that takes care of the requirements of DrawRect. Let's try this one first. So can I see the player's rectangle or collision rectangle when I'm in debug mode? Okay, let's try it and see if it works. I'm going to press play. And when we do so, and I press the H key, oh man, what the heck? How come it's down here? Well, it's down here because I told it to go to the position and start drawing from here. This is the position of the player, the actual position. In fact, the position of the player and any other object in my game is centered. I don't have a tool that's inside of my util DrawRect to say if it's centered or not, right? So we have to account for this by marching back half a width for position, and we're going to march up half a height for position. So we can have our top left corner there. And the way to do that, I'm just going to put this on separate lines here so you can see this. The way to do that is to do something that looks like this. I'm going to say, okay, give me the position of the player, subtract a new GLM vec2 object, and the new GLM vec2 object I'm going to subtract is the player's width times 0.5 and the player's height times 0.5. So I'm subtracting half the width and half the height. Okay? Oh. If I can type anything at all today. Alright, so that's this. That is the... So what I've done is I've said, okay, for the position parameter, I need to take the position of the player and I want to subtract a new vector, which is half the width of the player and half the height of the player. Okay, that's what I'm doing there. By the way, a lot of times I make half width and half height, right? In this case, I did not. But for some game objects, sometimes I make this engine and I have half width and half height because it's so commonly used. All right, so if this is right, let's see if that works. Let's go back and see if I can run the code, and it's going to show me the drawing the collision rectangle around the right place. It should work now. Okay, again, I'm going here. I'm pressing the H key, which is turning on the collision rectangle. Right? If I turn it off, it's good. If I move my player around, it also moves with the player. Why? Because this is only being drawn during in the draw function, and it's only being drawn with my my debug mode on. So if I move them around and if I press H, you can see that debug mode turns it on, and it shows us that debug mode is on or off. That's pretty good. Let's do the other ones. So again, I'm going to copy this whole thing, this DrawRect, and I want to get the plane as well as the obstacle. I know the obstacle is already rectangular, but it's okay to get the obstacle in there too. So plane, obstacle, and let's rename these things. So instead of player for this part, I'm going to say M_P, and it's going to be plane sprite, this one, and I'm just going to copy paste this part, the name, over top of anywhere I have player right here. I'm just going to do it by hand. I could copy, find replace, but I'm just going to do it this way. So a few replacements, and if I press save, that's done for the player, for the plane sprite. Let's do the same thing for obstacle. So I'm going to say M_P obstacle, this one. And I'm going to say that let's just replace anywhere that it says player again with obstacle. So obstacle, 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 and obstacle. And that takes care of the player, the plane, and the obstacle's collision boundary. Let's see. If I run it, again, we could do this differently with a different way, but if I press H now, you can see I've got a collision boundary here, and I have a collision boundary really tight around the rectangle, and a collision boundary here, and I can move my player around, the line moves, and I can turn it off and on. This is pretty good, right? So that is that part, but there really isn't a collision, so technically you need to have collision detection in place for this to work, and I'm going to do that in the update function. So right now the collision manager just does a line of sight check. I want to do an AABB type check between my player and the plane sprite, and my player and the obstacle, and I need to change my collision manager AABB to account for this. So let's do it first. Collision manager, and I go AABB check, right? And I'm going to go from M_P player, so this guy, and I want to check with M_P plane sprite. Does the player connect with the plane? That's what I'm saying. And I'm going to do the same check. This is in the update function. If the player connects with the obstacle. Now, if you had more than one obstacle here, you would do a loop and loop through all the obstacles that you want to check to see if there's a collision detection. And you would do different things here when you collide with the plane compared to if you're colliding with the player. All right, so good. We've done this, but the problem is we haven't done anything in the collision manager to account for this. So I'm going to right click on AABB check, and I'm going to go to definition. And then in the AABB checked method, scroll down, and we're only listening for one thing, which is something called target. That doesn't make sense. We want to say that if the type of the thing that I'm colliding with, the player's colliding with, is an obstacle, then say collision with obstacle. And I don't want to make a sound. Let's just turn this sound off for now. All right, and I can do another case where I can say that, hey, collision with instead of obstacle, it'll be plane. If the player collides with the plane, which is the enemy, then collision with plane. Now I've taken over the bare bones scaffolding of my collision detection for the player, the plane, and the obstacle. That's what I've done. Okay? And I'm able to show it in a debug view. Guys, this is a great place to put this all up on GitHub. Let's do it together now. So I'm going to go to, first of all, are you with me before we go to GitHub? Or do you want me to go back? I got a check mark from Oliver. Got a check mark from Juan. And Paul is good. And I know Shabham, you came in afterwards, Shabham. So you're going to have to follow along as best you can and maybe watch the video later to submit your lab, which is due tomorrow night at midnight. All right, so yeah, so this is good. I'm going to go to Team Explorer. I'm going to bring back Team Explorer, right? Here's Team Explorer. And if you can't get Team Explorer, if you lost it somehow, again, you can go to View, Team Explorer, right? That's how you get it. So Team Explorer, I'm going to go to Home. I'm going to go to Changes. And under Changes, you're going to see a bunch of these changes. Look, I've updated my executable. I've also changed my collision manager, my placeScene.h and placeScene.cpp. And this is a great place to say added debug view, right? That's a new feature I added, right? So commit all. There we go. And then I'm going to go home, sync, and push. And if everything goes well, then we're going to push these changes to GitHub. And when we do this, if I go to online to GitHub, here's my account, you're going to see now that I have 5 commits. And you should have 5 commits at this point, right? So notice that I have a few commits I did before, and you're going to have 2 new ones from yourself that you just did. Okay? Are you guys with me? Check mark for yes, X for no. You guys are getting fast. Ooh. Man, I wish I had all this kind of response in the first class. Right? No disrespect to anybody. Just it is what it is. All right, so okay, so this is pretty good. So we've got a few, a couple of commits here, and let's get going with other stuff. And the alarm is going to go off in my house today. Why not? Someone is cooking. That's what happens when you're broadcasting from home. All right, so yeah, so we've done this part. We've made the collision manager work, but what we really want to do now is in my placeScene.cpp, let's go back to there. I'm just going to give myself some more real estate, and I want to continue adding additional functionality for my game. So we've covered a good part of this. Okay, we've done line of sight, which we've already quoted from last day. That was could be challenging. Detection radius, I'm going to leave to you. That's pretty simple. You just show a circle with the radius that you decide is the right radius for your base enemy class, right? And then a collider boundary, which we've done, and node points, which we haven't done. Node points are nodes that are in your scene. Now you can use nodes that are like we drew last time. We had this diagram that we were using last day that kind of looked like this, almost like our plan, if you will, right? And I put some random points, like node points, around the scene. But in order for us to do this, we need to define what a node is. This is a walking node or a path node. This is not a node from a tree structure like a decision tree or a behavior tree. It's a different kind of node. So this would be a game object, not a display object, a game object that does not display anything, but that has some kind of shape. And what I would recommend to you is that you have a little point, that the rectangle itself should be something like centered around the center of the node, right? The center point of the node, and it should be something like a 5 by 5 pixel rectangle that'll show up to show the position of the node. It doesn't have boundaries, it just has a position. So in order for us to show these little points on the screen, you want to position all these nodes. The other thing that you want to do is these nodes have to be strategic. When you build up your level, right? Notice I've scaffolded out some obstacles here, really roughly, right? These obstacles should not be like my obstacles are right now. Like, it should not be like this. If I run the code, as an example, when you do your assignment number 3, I'm just, kind of building this out slowly. And one thing it says is make a map that's interesting. Guys, this is not interesting. This is a placeholder graphic for my player. This is a placeholder graphic for my enemy. This is a placeholder graphic for my obstacle. Please replace this stuff with your own things, and maybe some kind of background, at least a color, solid color, like green for grass or brown for dirt or whatever you're going to make for your map. Okay, something that's more interesting than this. Okay, so that's right there. So you want to put these nodes strategically around the scene, so when you position your game to work, right, then you have these walking nodes. Now think about what the walking distance should be if I was going to patrol around here with your plane. If I'm going to do a patrol with your plane, a patrol state, if you will, how am I going to get from one node to the other? Am I going to use some kind of steering behavior? Am I going to use pathfinding? What am I going to do to get from one node to the other? That's really up to you how you want to patrol. My take would be that I want to go to the next node and I want to use kind of a steering behavior to get there. It's going to go from one node to the other. When I get there, it's going to go to the next one. Let's go to the next one, and it's going to go to the next one, and it's going to flow literally by, by the speed of whatever the enemy is. Also, what would be nice is if the enemy looks in the direction that they're walking, right, around the nodes. It would not be cool if this is the plane and if it just literally just goes to the side and backwards. Okay, that would not be good. You want to turn so it looks in your direction. So there's some work to be done on enemy movement and player movement as well. Okay? But that's not what we're going to be handling today. What we're going to be trying to get today done is this part, which is I want to start off with debug keys. We already did the debug key H. I want to add in a key for the K key as well as a key for the P key. I would like to try and do that, at least to scaffold out what this would look like for you guys. All right? So let's go back to this. Again, we've got some points here right now. I've given you some points here from the scene because the start scene is like almost complete, really, at the end of the day. It's got like you have to just change the text, and you've got 5 free points out of 100. So 5% is free. I'm giving you another probably 5% here. That's 10% of this thing that I've built out for you. And there's things you have to change here on your own to make it more interesting. All right, let's get back to this. So I'm going to scroll down again to the handle events function. And on the handle events function, I have this M_B H pressed. And then I'm like, wait a minute. I got to do the same thing for my, K key and the P key. K for killing and P for patrolling, right? I'm going to have to make 2 more Booleans. And I guess I could, right? This is where it becomes bad, right? I could do this. I could say like bool M_B, K pressed, right? And I could do another one, bool M_P B, P pressed. And maybe I have other ones in the future, right? Whatever. This is really inefficient. I'm making a Boolean after a Boolean after a Boolean. What's better is if I use, instead of this structure, I used an array of Booleans that I kept track of stuff. Okay? An array of Booleans. Okay, how would I do that? So let's get rid of H pressed. We're going to do it for all of them. All right? So I'm going to make a Boolean array. So it's going to be M_B debug keys is what we're going to call them, right? And it's going to be an array. I can't just do this though. I've got to specify a size for my array. I can't. This is not enough if I did M_P debug keys. This is bad, right? I got to specify how big the array is, and the way I would do this, right, as an example, is if I had some keys. I don't want to put 0, 1, 2, 3 in there. That doesn't make any sense, because maybe I could hard code it to 3. I know there's only 3 right now, but what if there's 4, 5, 6, 10 more in the future? I want to do other kind of debug things. And by the way, if you look at assignment number 4, there's more things I want you to do, right? So you want to prepare yourself for the future, so you don't want to do this exactly. I want to go to my Solution Explorer now, and I want to add some friendly enumerations to help me with the keys. So I'm going to go to my enums, right-click on enums, add a new structure, a new item. I'm going to make sure that I use the .h template and go into, call this my debug keys, .h. I'm going to change from template, you have to do this, to src. It's got to go in the src folder. If you don't, you'll never be able to see the debug keys or reference them. That's the first thing. Okay? I'm going to click add here. And what it's going to do is in my enums filter, it's going to create a new file called debugkeys.h. I'm going to say if not defined debug keys, and then I'm going to define debug keys. And I'm going to say that end if, and typically what I do is defined debug keys. Okay, so that's kind of an important step. So debug keys, if defined debug keys, good. And then I'm going to make an enum, right? So enum, and it's going to be called debug keys. That's the container. It's not going to use, we're not going to use enum classes here, so that would be an improvement. Here we're just going to use regular enums, and we're going to say the first key is the H key, right? And the second one we said was going to be the K key, and the other one is the P key for patrol, and we might have other ones. But we also want to put another value called number of debug keys. We don't know how many there's going to be, so this value here keeps track of how many. Right now there's only 3, and if I hover over a number of debug keys, you can see the value is 3. So this talks about how many values there are. These are the actual values themselves, 0, 1, 2. Are you with me? Check mark for yes, X for no. That's good. Let's see if Oliver is going to join us with the check marks. Yes, excellent, Oliver. You're awesome, guys. That's fantastic. Okay, great. So that is good. We've gone and done this enum, H key, K key, P key. We can add as many as we want now. And I'm going to save it. Go back to my placescene.h, and inside M_B debug keys, I'm going to specify number of. But I want to do it. In order for us to do this, we have to include the debug keys. If I go debug keys, and if I do one of those, it's going to say Resharp or C++ is going to recommend including debug keys.h, which I want to. And now I can just say number of debug keys. And when I do that, I can just remove this part because this qualifier is something I don't need. So what this does is it says, hey, I need 3. If I add another one, right? If I go down to debug keys and add another one now, let's say the T key for whatever reason that's going to do. And if I save this, and if I go back to placescene.h and I hover over this, now it says 4. And so it's a dynamic way of adding as many keys as I want. If I add one to the debug keys, it'll just add another one in the array. And that's a kind of a great way of doing things. I'm going to go back to 3. All right, so now that I've got debug keys, I got to change the way my code works. So it doesn't use M_B H pressed. It doesn't use that anymore. It uses debug keys H key. Okay. So that means if I go back to my placescene.h, I'm going to have some errors. See? M_B H pressed. It's not going to be this anymore. It's going to be M_B debug keys, and then inside here, the H key. That's the one that's been pressed, right? If the H key has been pressed already, that's what I'm saying here, right? I'm going to copy this part. Then I want to make it true, right? It's already been pressed. Or if I stop pressing it, then I want to make it false. I can also remove it from here because like I said, by default, we didn't have to do this. By default, they're all false anyway until I specify otherwise. So that is a great way of making us use these. It's more descriptive, H key, as opposed to some weird Boolean, right? It says debug keys, M_debug keys, the H key. If it's not, if that hasn't been pressed as an example, then we know we can listen for the H key to be pressed. Otherwise, it'll just be a continuous press problem that we had before. Let's see if this works. We should test it now, this change we just made. So I'm going to go here, run it. And again, I think my motto has always been make it work. After it works, refactor. And I think that's what I've done. I've refactored it a little bit so to make it a little bit more efficient. Again, we have some additional work to do to refactor even more. There's always opportunities throughout the entire code base to find places to refactor. Okay. All right, cool. So if I press H now, it turns on and turns on and turns on. If I press it off, so I can toggle on and off, and it still works the exact same way with slightly better visuals on our code. But what it really helps us with is the next part, because I want to do the same thing with the P key and the K key. So K kind of turns on damage. That's what it does, right? So I say, okay, I want to do damage to the enemy. So let's do that next. So I want to kind of copy all this. All right, same structure, and I can actually say this is the H key section. So when I'm listening to the H key, just to be descriptive, and this one will be the K key section, and I can change this. I can say, okay, if the K key, right, if it's not being pressed, then listen for the K key. Just replace now, and we're not toggling debug mode on anymore, so this is gone. We're actually doing damage. So I'm going to say std out debug, enemy enemies. We'll say enemies taking damage. Okay, so it's a debug. We're making it happen, and I'm putting debug in there so we know that I triggered it. It's not being taking damage from some other reason. Okay, we're saying that the K key now is true. It's been pressed already, and we don't need this part right here because we don't have a mode we're switching to. We're not actually switching from one mode to the other. So that takes care of this. Did we just mess things up? Or did I just copy it wrong? Oh, I just copied it wrong. I copied part of it, but not the whole thing. Yeah, so, and this scan code K, all right, is the one we're going to use. If it's key up, then what we want to do is we want to say that this is false. This is false. So that takes care of the K key. K key section. All right, let's work. So let's just run it. All right, and if I press K, then the enemy's taking damage. And if I keep pressing, if I hold it, nothing happens. But if I keep pressing it, I keep doing damage to the enemy. So it's a great way of testing to see that this stuff is working. Okay, pretty good. Yeah, excellent. So that is the K key. Let's do the same thing for the P key, but in this case, I'm not going to do this. This doesn't make as much sense as using this because I'm going to have a mode. I'm going to have patrol mode, or I'm going to turn it on and off. Now I could also have a state, patrol state on and off, but for now I'm just going to call it a mode. So again, I'm going to go to placing.h, and add another mode. And you're going to see that, uh-oh, wait, M_B, patrol mode, right? And you're going to say, wait. Now, isn't there an opportunity, Tom, to make a mode array or a mode enumeration? Yes, there is. There is a way we can do that, but we should probably wait until we get to the second part of this thing, because there might be other things we need, right? For now, it's okay just to have a couple of booleans that are here as flags. I'm okay with this one. Just to be complete, I'm going to take patrol mode and make it false inside of the placeScene.cpp inside of the start scene, so our start function. So start, I'm going to say that my patrol mode, well, that's equal to false. So the enemy's not patrolling in the beginning. Okay, so that's false. And then I'm going to grab that H key, because the H key is almost identical in structure to what we want to do with the P key, right? Because we're going to turn it on and off. So we're going to go here, grab all this. We're going to go under the K section, and just down in here, we're going to make that happen, where we're going to say this is the P key section. So we know that this is where we control the P key. We're going to say P key is here, scan code P, right? Toggles patrol mode on and off, right? Or we say patrol mode M_B. Patrol mode is equal to not patrol mode, so either on or off. We can say that patrol mode is going to turn debug, so debug will say patrol mode on. See where I'm changing this, so you can see that this is just a placeholder for turning on and turning off patrol mode. We would put the actual logic somewhere in here, right? But there's no logic right now. We're just scaffolding out our keys. That's all we're doing. So P key, and here we're going to make this the P key as well. Debug keys, P key is true, right? And then when we stop pressing the P key, down in here, P key and P key. Okay, nice. And that takes care of patrol mode. So patrol mode gets turned off. Patrol mode gets turned on, or whatever, on and off, right? And making sure that this is the P key, K keys, all that says K key, all this says P keys. Let's try this out and see if it works. So again, I'm going to turn this on. And when it works, I'm going to have 3 keys that I've defined that do things in the view. Again, it doesn't take long, and I'm going really slow. But you want to do this first. If you do this first, then I have a mechanism now that I can do damage, or I can make patrol. I can test some stuff out, right? Because I didn't have that before. All right, so you can see the keys here. If I press the P key, patrol mode is on. P key again, patrol mode is off. K key, the enemies are taking damage. H key, I want to turn on my my debug mode. H key again, debug mode is off. P key, patrol mode is on. P key, patrol mode is off. So you see how that works, right? Nice and easy. And that's the first part of your debugging. You want to start off with this because it's going to help us do functionality later. It's going to help us troubleshoot functionality on and off, right? And going back to our things here that we have here, we'll see what it says. The user will be able to activate certain effects by pressing various keys. When the K key is pressed, the base enemy will take damage. Well, we haven't done the damage, so you've got part of it working already. And when the P key is pressed, the base enemy's movement will be toggled between idle and patrol. Okay? So we do switch, but we don't actually move. So right now you're getting like 1 point out of 2. Right? We're getting some points here. So we've got some stuff that we're scaffolding out. And you can see that it takes a while to get everything going. That's why I'm telling you guys, use this as a method to start off your project, your assignment 3, because it takes a while to get things done. It's not something that you can do overnight. It takes time. It takes hours to do properly. Okay? Let's put this up on GitHub now. So again, we're going to push the next one. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. And it's going to show me the changes that I made. So I made a new executable. I added the debug keys.h as well as the place scene and the place scene.h modified. So let's say that we added debug keys. We added the patrol, the K and P keys. Okay, that's what we did. And we're going to commit all. I'm going to go to home. I'm going to go to sync. And I'm going to go to push. And there, my friends, you have the next commit. The next commit, which is up here. If I press refresh, you can see now that we have 6 commits. You should have at least 6 commits now, right? And you can have all these commits. Are you with me? Oh, Paul, you have a question. If it works in the engine, what do you mean by that? Do you mean that, like, if the patrol is actually happening, I don't see anything on the screen that tells me that it's working? I mean, you know, it doesn't matter to me if you output to the console or not. I'm outputting to the console because it makes sense for me to do it, right? Yeah, but it works from that it turns on and off, but there's nothing actually happening. I'm not actually moving. I'm not patrolling. I'm just turning on. That black window is the console. That's part of VS Code, right? I've turned on the console. So when I press the debugger, when I'm debugging, this black window here, right? It's basically showing. It's a console that lets me understand what's happening, from my application, right? Now I've turned this console on. It doesn't get on by default, by the way. I've turned it on in main. So if you go to Solution Explorer, just understand the anatomy of your app here. And if you go to the main scene, which is in core, if you go to core, and if you go to main.cpp, then notice that there is an alloc console here and a free open. All right, this shows the console. If I didn't have this part, then we wouldn't see the console. So let's say if I commented this part out like this, I comment it out, and if I run the code now, we should not see the console anymore, right, by default, right? I'm just showing you this because you're asking. So now we don't see the console. Console, no more console, right? That console gets turned on because I tell it to be turned on. So that's just a debug console for us. But that doesn't do anything. That actually doesn't change the functionality of the code. All that did for us, right, is we created a structure for me to put the code inside of. For example, the H key is working. We've turned on debugging mode on and off. This part, that works exactly as it should, right? However, the K key is supposed to do damage to the enemy, but there's no enemy, and we're not monitoring any kind of damage, right? And the P key is supposed to make the enemy move. That's what it says, right? So the P key says when the P key is pressed, the base enemy's movement will be toggled between idle and patrol. It doesn't do that. It just, right now we're just listening for the P key and the K key to be pressed. So we've got partial debug keys working. Okay, that's how it works. So you're not actually getting any points for that part. Remember, we still have to define our enemy. So if I scroll down here, it says there's player animation and sound effects, player combat capabilities, obstacles, and this is the next thing, the base enemy setup, which is mandatory. Okay, so base enemy setup, if you look what it says your game will include a base enemy class. The base enemy class will move patrol along predetermined path of nodes around the map. So for me to do this, I need this, nodes. And actually, we've been talking about nodes a couple places. So that is the next class that I will define, nodes. And the nodes will just be locations on a map, right? So it really depends on how you're going to do this. Are you going to put equally spaced nodes around your map based on the width and the height? Are you going to predetermine your nodes based on your map tiles, how they have what you see in the front, as an example? Are you going to use a tile map, which is going to load like images or whatever to make your map look nice? It really depends. But for now, for us, a node is going to have a couple of things. right? It's going to do a couple of things. Remember, just like our drawing, each of these nodes is probably going to be equally spaced around the entire scene, okay? However, just to keep in mind, right, that if I put a node inside of an obstacle, like here and here, this node will have 0 line of sight, and it'll be unwalkable, right? It'll be impassable. So nodes should have, can I get there? Like, is it passable or impassable, right? That's another thing. And which means that you may want to think about how to do that, right? Am I going to collide with my my obstacles? Is it going to be something, if the node exists, if I populate my entire screen with nodes, as an example, there's advantage and disadvantage to this. Or am I going to pre-do my level? Am I going to make my level so that I populate my nodes in certain spots? It's really up to you how you want to do this. If you want to do like an automatic node layout, it's very similar to a grid, right? I got to figure how many of these nodes I'm going to put on the map. And that's my next step. And if they're walkable, can I get there or not? You know, walkable, yes or no. And you can also make it so that some of these nodes have a higher cost to get to, just like you would in some kind of tile map. All right? So let's do that next. Now, I didn't get there with the other class, the other section, but we're going to get there with you guys. So we'll have another commit. All right, so a node is a game object. We know that. I'm just going to close some of these down for a second, okay? Just to clean up. And then we'll stop after this because we're getting into 420. And it's going to take more time to do. So we want to make a game object called a node. A node is a game object, and the node that we're talking about is a path node. Okay, it's not a node of a tree node. This is a path node, so a place to walk. Okay, it's almost like a tile, like when we did tiles in the previous two, in one of the previous assignments, when you did pathfinding, right? You used tiles, and the tiles knew their closest neighbors. They had a map of neighbors as an example, and you can go from one tile to the next. Here, we don't have that. We just have positions on a map, okay? Each of these positions on a map will be able to do this. It will have either line of sight with the player or not. So let's scaffold this up, because remember what I did before. I said, if I have these nodes, I should be able to draw a line from the node to the player. And if I can draw a line from the node to the player, I can turn this on, right, as an example. If I can draw a line, I have line of sight. If I can't draw the line, I have no line of sight. So each of these nodes, when the player moves, is going to produce line of sight or no line of sight from the node to the player. Why? Because if the node doesn't have line of sight, that means that's a place where I can hide. If I was the enemy, I can go to that node, right? So let's make that first. So again, I'm going to go to Game Objects. I'm going to add a new item. Again, this is net new. For the people who weren't here or who didn't do this in the last section, it was because it took long for us to get set up. I'm going to go and make this, I'm going to call this thing a path node. There might be more than one type of node. So here's my path node .h. I'm going to add that in. And I'm also going to add a path node.cpp. So add a new path node, new item, right? And I'm going to call this path node.cpp. All right. So path node.cpp, immediately I'm going to say import path node.h. Okay. And what I mean is include, not import. I'll be okay. See, what happens is I'm thinking Python, I'm thinking of the languages. I'm like, my mind is all over the place because, you know, path node.h. And path node.h is here. We're going to do the same trick. We're going to say if not defined path node, then I want to define path node. And I want to put an end if defined path node. So again, we want to be smart. I want to include all the things that a path node class would have. So I'm going to say that this is a class called path node. It inherits from GameObject, not DisplayObject, because DisplayObject actually gets an update, but it gets added to the display list. I don't want to add my nodes to the display list. They're not going to show anything. There's not going to even be a draw function for these things at the end of the day, right? What I want instead is that my my path nodes, right, are going to be just positions, right? And I want to keep track of the position. So GameObject is the right choice, right? Remember what GameObject gives us. If I was going to go to GameObject from a core perspective, GameObject is a core class. GameObject.h gives us the draw, update, and clean methods. Now, theoretically, we could probably get rid of the draw method from the GameObject, because that should be part of the display object, not the GameObject superclass. For now, though, we're going to keep this as is. Later on, if we were going to refactor it, we'd remove draw from GameObject. Update and clean we would definitely want the update part. But my draw part's going to remain empty. I'm not going to draw anything in my display object for this one. Okay. Transform and rigid body. Okay, my game object, it's a game object, but it won't need a collider. I don't care that there will be some kind of collision with the rigid body. So theoretically, game objects may not have a rigid body. Again, this is the flaw in our monolithic class that we're making for our little assignment game engine. Right, that's what it is. Get width, get height, and all this stuff is important because we need to know where it is and how wide it is and so on, what we're looking at. For example, if I'm making a death plane at the bottom of a platform, then I'd want to know the width and the height of it. Okay, I want setters and getters for this. So there's some stuff that's extra. We're getting extra things that we don't need, but we're getting less extra things than if we made it a display object. A display object is different than a game object in that we not only get the game object stuff, but we also get a parent, a get parent, and a set parent, where I can add it to the scene. So I don't want to add the ability for me to add it to the scene because the scene's not going to show or keep track of the display. These aren't display objects. These are just game objects. They're just objects that I want to keep track of position. Okay, so that's one thing. And they're definitely not UI objects because UI objects are like specialized forms of display objects, right? Like another further down the pipe, right? So they're definitely game objects. I think that's the best way of describing them for now. We may decide to make them display objects for other reasons, but for now, path node should just be game objects. Okay, we want to do this. We want to go to the little hammer, and I want to say generate missing members, which will generate draw, update, and clean. Now remember that from a draw, update, and clean perspective, you may not want the draw function even defined because we're not going to use it, okay? But it's okay to keep it like this, override, okay? So here's my path node. These are the lifecycle functions. So we're going to say lifecycle functions. Okay, we also need a constructor and destructor for each of the path nodes. So we're going to say path node constructor and also path node destructor. Okay, so those two things. And now I want to generate definitions by declarations. So I want to go here again and go generate, try that again, generate definitions by declarations. This is all part of the ReSharper Ultimate kind of for C++ method extension, which I recommended to you earlier this semester. And it does these for me. My path node, that can be default, so I can kind of say this can be my destructor could be a default destructor, and my draw function will be unimplemented, right? So I'll leave it empty. Update and clean, well, clean will probably be empty for now, but update is the thing we're going to work on the most because this is where we're going to do stuff with the function. So far, it's just a game object. That's all that path node is. But actually what we want more from it is we want a private area to denote some members, some data members. One thing we want from this is the ability for us to know if we have line of sight or not. It's going to be a Boolean that we check on and off. Do we have line of sight with the player, right? So we're going to call it M underscore, and it's got to be a Boolean, M underscore B, line of sight, okay? You can call it M underscore B line of sight or just LOS. It's going to be a bool, all right, that all path nodes are going to have, okay? And we want to be able to turn on the line of capability, right, whenever we need to. So whenever the we can do it every frame if we want, and that's expensive. But let's try and do it. Let's try and create we're going to create a sense of us, generating our line of sight every frame. So M underscore B line of sight is going to start off as false. There's no line of sight. We can always initialize it in the here in the constructor function. So we can say M underscore B line of sight is false. We could do that, although it starts false anyway. So that's kind of a good practice to do, right? And then that's one of the reasons why we want path nodes. The other one is we can use the draw function, even though it's not a drawable. We can use the draw function for the path node if debugging is on. If debugging is on, right? So we don't want to draw anything to it, as an example, if debugging is off, right? We don't want to do that, okay? Or we can do it in the scene. It's up to you. But every frame, we want to check to see if we've got line of sight. So we're going to say that, hey, collision manager, at least for now, hey, collision manager, I want to do a line of sight check, all right? I want to do a line of sight check between me, this particular, object, as an example, and the player. So there's a couple ways to do this. I can't do it here because I don't have access to the from. I don't have access to the to, and I don't have access to the obstacle. There's no obstacles that I have access to here. But I want to do this in the update somehow of my object. So for now, we're not going to do it here. I could pass references to all the obstacles for all the path nodes. I could do that, right? And I could pass references to the player to all the path nodes as well. That's what I can do as well. But we need to somehow inform them. The path nodes are going to be semi-intelligent. And they might also know their nearest neighbor. What is the nearest node, if there is, or a list of near nodes to the path node? That's something that you want to also check, right? How it knows when you load all the other nodes, and what do we have adjacency information at all, right, or not, right? For now, we're going to load these up with, they're going to be a little bit dumber because you need to do some work too, right? So, so here's my line of sight. We want to keep track of line of sight somehow. So we want to make a setter to do that. So set line of sight is what we want to do here. All right. So I'm going to make a public function, and we're going to make get line of sight and set line of sight. So set line of sight, right? It's going to return void, and it's going to take a Boolean line of sight, right? And also we're going to return line of sight. Okay, so we're going to say that a bool get line of sight from this node. We're going to remember what we had, and we're going to be able to get line of sight from it. We don't have to check it again every single time. Okay, so it's going to be a getter and a setter. Again, what I can do is I can go here and I can just check on generate definitions by declaration. We're going to add in set line of sight and get line of sight, which are going to give me these two methods. Set line of sight is going to basically say I have line of sight, so I can do it outside of here, which is smart. I can say that M_B line of sight, this one, is equal to line of sight. Do I have line of sight? Yes or no? I'm going to get it from here. It gives me this check. I always like listening to ReSharp or C++. I'm going to click onto this, and then a lot of times what it does, it says add const. I'm good with that. Const is good. And it also tells me rename this to like lowercase line of sight. Nah, this means something, LOS. So I'm going to keep this up here. And then from a return perspective, return M_B line of sight. I know that I'm returning it out. It does say that this is probably going to say make const, right? Which makes return a variable that's going to come out. So this is good. Okay. So I'm going to be able to set and get line of sight. All I'm doing is setting up the structure for what I'm going to be doing here when I set these nodes up. I'm setting up line of sight capabilities, the ability for me to know if there's line of sight with me and the player, and also a position for where the next walking nodes are, right? You can set up nodes everywhere, like I said, or you can set them up strategically on the map with some kind of boundary. Maybe you want to create boundaries for the nodes. For example, maybe you want to make the boundaries equal to the tile size of your map. In this case, you would have almost like a rectangle that you would use for the boundaries, a width and a height. And we have that information. The width and the height, because this is a game object, we could set the width and the height here. And because all game objects have width and height, remember? If I go to core, and if I go to GameObject.h, GameObject.h indeed has set and get width and height. And we also need to set type. We don't have path node as a type, and we should set that up in our game object type enumeration. So if I go to my enums, game object type is something we need to modify. I got none, ship, target, player, plane, blah, blah, whatever. I want to add in path node. That is our type of game object. Okay? So path node is a type. Now, we just added it in. Cool. All right. And what we want to do is assign some information in the constructor function. So in the constructor function of path node, that's up here, we've initialized line of sight. But what we want to do is we want to set up some stuff. I want to say that set width. And now this is up to you, what you want to do. I like to set the width to the tile size. My tile size is going to be 40 by 40. Why is that? Because if I think about my tiles, I'm going to load a tile map. And if I think about the tiles, if my screen is 800 by 600, and if I divide it by 40, then I'm going to have 20 tiles across, right? And if I have my tiles that are 600 high, so 800 wide by 600 high, that's my screen size. And if I divide that by 40, I'm going to have 15 tiles high. So 40 by 40 is what I want to set my tile size to, right? That's how big my tile sizes are going to be. So again, I'm going to say set width, and I'm going to say 40 by 40. So 40, right? Now remember that get width and set width, it needs an integer. We don't need 40f, just 40, right? And the same thing goes with set width and height. Set width is 40. Set height, that's 40, right? That's the width and height of each of the tiles, right? And what this does is it gives a separation. So for example, I have a automatic padding, right, to the tile. Even though you can't see the path nodes, there's going to be a space, a radius, if you will, of 20 pixels, right? Almost a radius of 20 pixels from the center, right, where the tile is. Okay, so to kind of show you where those tiles are. 40 by 40. And I want to set the type. Set type, right? I want to set the type to path nodes, right? It's a path node type. So I know it's not like I'm not colliding with it or whatever. It's a path node type. I can identify that it's a path node that I'm colliding with if I need to do collision detection, right? And I can also use AABB style collision detection between my path node and my my player or my enemy. I can detect when I'm in that particular tile if I need to. Right now I don't need to, but maybe in the future I might. So I'm going to put it in there so that I can. I also want to set some. I could set my transforms position for all this, but I'm not going to. I want to set the transform position automatically with my my grid. I'm going to make kind of a grid of tiles after this that I'm going to load. Okay, so that's what my tile looks like. My path node looks like it's pretty much complete for now. It has line of sight capabilities. It can detect line of sight. It has a position. Now let's go and put it up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. There's some changes that have been made. I made changes too. My game object type, my path node, CPP, and .h got added, right? And I've updated my template, right? Let us say added path node. Okay, commit all, home, sync, and push. Okay, so guys, again, I'm looking at the three guys. Oliver, Paul, it's one, right? Are we good? Oliver's good. Paul, you're awesome, guys. That's great. You guys are following along. So running out of time, we want to make, what I want to do now is show the path nodes. That's all I can do. That's all I have time for. I want to show the path nodes, and I want to plot them on my map evenly. Now this may not work for you. You may decide to do a different way later on, go a different direction. But I'm going to plot them in my scene. So in my play scene.h right now, I want to make a grid of path nodes. So I'm going to call this thing grid. It's going to be of type vector. So I'm going to say standard vector, right? And I want to make it of type tile pointers. So it's basically going to be path node pointers, right? And the path node pointers, it says, hey, I don't know what path node is. Let's add it in. Sure, there you go. Path node is now there. I'm going to call this, we'll call it grid. M underscore pointer. It's going to be a pointer vector of type grid. So it's going to be a grid. I don't have to do this, but I can specify how many, and what I want to do is in my play scene, I'm going to have a private method. So these are member variables. We can kind of break this down now. So these are member variables. Right here, I can have private methods or functions. We'll call them functions here because it's C++. And we'll make this private function build grid. M underscore build grid. And when build grid gets called, it's going to add path nodes to the grid systematically. So I'm going to go here to this, right, as an example. And what I want to do is I want to kind of declare this one. So again, I can do just the same trick as before. I can just generate definition by declaration, right, which is build grid. It's at the bottom, right? So it's underneath our start scene. It doesn't really matter where I put it. I've put it kind of at the bottom. I'd like to move it before the start scene just because I can see it this way, my start scene. I'm going to build my grid before I do pretty much anything else. So I'm going to call build grid in my start scene. So M underscore B build grid. Okay. And the way build grid is going to work is it's going to create a 20 tiles wide and 15 tiles high. That's what I want to do. That's how many I want to add. So here, logic to add path nodes to the scene. Okay. Now you don't have to do it this way. You can also plot it manually. It's up to you, right? So I want to say that I want to make a for loop, right? And my for loop is going to be, for I, and then where the total number of tiles, I want to keep track of all the tiles in one continuous vector. So that means that I want a vector that is 15 by 20. I'm not going to use a two-dimensional array. I'm just going to use a vector of 300 path nodes. All right, that's what I'm going to do. Why? 20 path nodes to per row, and there's going to be 15 rows. So here I'm just going to make this 300. Now you can make whatever you want. You can say that it's the size, number of rows and columns. And for this, what you want to do is, if you're going to go there, row times column, that's the size, right, that I want to add. I could say that I could do this in a nested for loop. So in my, if I'm not wrong, I have a utility here. So I have, in my core, I have something called config. So my config, I have row number and column number already for you. And I've already created tile size, which is interesting. So I could have used this in my tile. And I recommend this, by the way, tile size, just like I did before. So I'm going to go back into my tile and fix this problem really quickly while I'm running out of time. That's what happens. So here's my path node. And instead of hard coding how wide they are, so this, I'm going to say that I'm going to include them in config. I'm going to say config, and then I'm going to say, tile size is what I wanted here. Config tile size. Now notice that worked because Collision Manager knows about config. That's better, because then if I change my tile size later on, then the path nodes will change size too. Okay? So if that's true, if that's the size, then inside of my place scene, then instead of me hard coding this to 300, let me do this again. So for I, and I can say that I want to do per row and then columns inside, right? So I'm going to say for every row, I'm going to have 15 rows, right? So again, it's going to be 15 rows. So it's going to be config and then row number. Right? Oops. If I can do this right. Row num, right? And then another for loop inside, for I, where I'm going to call this column. And it's going to be config column num. Column num. I hate when it does that. And inside here, I'm going to instantiate and add to my vector a bunch of tiles, path nodes. So in here I'm going to say m_b, my grid, right? My p grid, right? My grid, and I want to push back a new tile, right? I want a new path node. All right. I want to push a path node to the grid. But what I want to do is with my path node is I just don't want to randomly add path nodes, like 300 path nodes. I want to put them in a special spot. So what they're going to start off is 20 to the right and 20 down, right? That's the new location of this particular path node, which means before I push back, I want to configure. So I'm going to say something like auto, path node is equal to new path node. I'm going to pass in path node in here. And I'm going to configure my path node with the set transform and get transform. So I'm going to say get transform dot set position. I want to get the position. So let's try this again. Set height, width, and so on. But I want to do the transform position, right? So again, each path node is a game object, right? So if I do, notice I have all these get transform, and then if I go dot position, right? I can say that the position is equal to a new GLM vec2 object, because that's what it is. It's a two-dimensional thing where I set the row and column in here. Okay. Now notice what it says here. right? It says that member is inaccessible, get transform. So what do I need to do here instead? Path node, get position. Well, because path node .h we defined as a game object, but we need to make this public. So that was an issue that we have to fix. If we don't make this public, then we can't access it. So if I go back to my placing.cpp, I'm running out of time, guys. I'm so sorry. Now I can do this. And what I want to do here with my position is I want to specify that it's going to start off at 0, right, on my x-axis, right? And I'm going to multiply this by for every row, right? So think about this. I'm going to start off with 0, 0, and I'm going to add my row number multiplied by my row number. So whatever my column is, right? Column. If column is 0, right? This is where it starts off. So that's column. That's the x-axis. So column, right? 0, and then row. So I want to do that, right? So column and row, and I want to multiply these by my width and my height, right? So width and height. So that's what it's going to have. But it's not going to be the full width. It's going to be half width and half height, right? So column, so half width. So get, so path node, get height, right? Multiplied by row, by column, sorry, and path node. Actually, this is get width multiplied by height. Sorry, get width multiplied by column, and path node get height multiplied by row. Now you're going to say, wait, how do you know all this? Because basically what I'm doing is I'm defining the position of each of my path nodes based on the number of rows and columns that I have. I can change auto, by the way. Notice it says auto. It says fix it, auto star. But I might as well make it what it is, which is path node pointer, which what I'm making. I'm making a temporary path node pointer, right? And it's going to tell me use auto. I'm serious. It's going to tell me this again. Auto, auto path node is equal to new path node, and then it's going to go back and say, wait, maybe you want to put it back as a star, path node star. It doesn't matter, right? So path node is equal to new path node is going to generate a new temporary path node, which is going to resolve when we leave here. Okay. So I'm making the path node, and then I'm adding it to the grid. I'm putting it in place, and this should give me, again, it should give me 300 path nodes through the entire grid space. Even neat. I don't mind. All right, cool. So that's what the build grid does. It just puts path nodes in a spot. Okay, it doesn't do anything else right now. Later on, we can add more intelligence to this thing, like before. Okay. Build the grid. Cool. Now in here we know that path nodes have been created. So in the update function, right? I don't care about updating them. They're not going to move anywhere right now, right? But what I want to do is for every path node, I want to check line of sight with the player, right? But for now, let me just draw the path nodes. So if debug mode is on, I'm going to go through and I'm going to call a function called well, I can do stuff for loop, right? And I want to draw the path nodes. I want to display my path nodes. That's what I want to do. So I don't have this function. I'm going to go to my play scene really quickly. I know I'm running out of time, guys. Give me a few more minutes, and then we'll be done. If you need to go, I understand. But what you need to submit just before we go, if you guys have to go, I know some people are tight with time. Some people asked earlier today what we need to submit for your lab. What you need to submit is this link right here. If you take this link, which is github.com, your account number, your GitHub account, and the link to your repo, you're going to go to the Lab 9 Dropbox and then submit in the comments the link to your Dropbox. That's all you need to do to submit your lab before tomorrow night at midnight when this is due. Okay. Just wanted to specify that just because before I continued, and then you might have questions later. Yeah, public is the thing to do. So then, void, right? I'm going to make this, should it be public? It absolutely should not be public, because remember that we're in the play scene itself. I'm only modifying the display grid here. So I'm going to say m underscore display grid. Well, you could make it public, but it's not required anyway. And then I'm just going to generate my implementation, right? So build grid and display grid, and they're going to be identical, right? So I'm going to say, I'm going to go here and put this in place. And instead of me going to do pushing and all that stuff, I'm not going to do this. I'm just going to output a square, if you will, wherever the nodes are. So they're just the grid, right? So what I want to use is the draw function. So util DrawRect, right? And I want to DrawRect in a position, which is the grid. So I'm going to say that n underscore p grid, and I want to know the row and column information. So column, row, and I want to get the position. Get transform dot position. That's what I want. All right. So that is going to be the first part of the DrawRect. Then the width and the height. So remember, this is the middle of my rectangle, right? And I need to go half width and half height, just like I did when I did this stuff, right? So I have an example of that already with my draw, right? So I might as well take an example here so I don't have to do a lot of typing. And let's go back down to here and put it in. So I'm just going to put this in here for now, and we're going to delete it afterwards. So position, and then the position is going to subtract the width and the height of the object, because I don't have that right now. So put that in place. All right. And this is going to, not obstacle, but the actual m underscore p grid row column row. So the column and row. So this is this. This is this. Right, and it says, if I hover over, it says expression result unused, column row. Oh yeah, it's not column row, it's the whole grid. Whatever that grid location is what I'm pushing back, right? So now this is something where I access the grid, right? So it's not column row, it's column, a number of columns, right? And it's row first, so the number of rows first, right? And then whatever the row is, that's going to be the location, and then plus column, right? So again, it's my row. So I start with row, and then the row is going to be a 0 to 19, or sorry, 0 to 15. So it starts with 0, right? And then I'm going to multiply that or add a number of columns. So I'm going to add plus columns, right? Row plus column, so 0 plus column, right? And if I do that for every one of them, if I say that if it's, for example, let's say if it's the second row, 2, right? I want to multiply it by the width, right, of the column. So row, so this would be the tile size. So config tile size, right? So it's 40, right? It's 40. Because that's what I'm saying. I'm saying that the tile size itself, right, which is the width and the height, is what's being added on. Width and the height is what's generating the position, width and height. So actually it's wrong. It's actually not tile size. It's column number. Column number. I'll be okay. So it's so row times column number. So if I say if the row is 0, then it's 0 plus the column, whatever the column happens to be, 1, 0, 1, 2, 3, 4, 5, all the way to 19. If it goes 1, right, then I would say 1 times the column number. So that would be like 1 times 20. And if it's the first one or the 0th one, it'll be 20. Or it'll go 20, 21, 22, 23, all the way to 29, and so on. and it'll keep doing it. So this is the addressing methodology, right? For each of the rows and columns, and that goes here, and that goes here. All right, so that particular row and column, all right? And then follow it up by the, that particular width and height is how big it's going to be. But instead of doing width and height, I'm just going to make it pretty small. I'm going to say that it's going to be like a 5 by 5 little dot. It's not going to take up the whole space. So I'm going to say that the width and the height is going to be 5 by 5. Okay? And that's only going to be displayed, this display grid is only going to work if and only if we're in debug mode. So way up here where I have my draw, I'm going to say that M underscore display grid is going to be called. Right? So that's only if I'm in debug mode. Okay, let's see if this all works or if it just like craps out. And let's see what the errors are. And then we'll be done. And again, you might say that this is like a lot of work to put grids, a whole grid on the screen, but really what we're doing is we're populating a group of game objects that are invisible to the player, right, along the entire size of the grid, right? And these invisible nodes are going to be used for path finding, for moving, and so on, right? And where I can define a path of grid tiles. And we're making them dumb right now, but you can make them as smart as you want. You can make them so that they know each other's neighbor, right? You can make them so that they have neighbor information, right? It's really up to you how intelligent or dumb you want to make them. Okay, cool. So I've got the grid. It's invisible. If I press H, then we see a bunch of grids. There's the grid tiles. Now, does it make sense? Because look, I have got some tiles that are missing up here. I got, let's see, 1, 2, 3, 4. I think we're offset. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that is interesting. We've got 19 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We should have 15. Right? 15 by 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We should have another one down here. And it should be offset. We're a little offset from everything that we have. But we're close. We're you know, this is kind of how it look in debug view. So we turn it on and you see that the, you know, kind of the nodes. These are all the locations of the nodes kind of thing. And that's what you kind of want. And the reason why this is showing up, there's a couple of reasons for all of these things, right? Let's go back to our grid generation. So it starts with this, right? So how many of these are going to be row number, so column and row, right? And I'm going to say, again, when I build a grid, I'm saying for every row from 0 to row num, where row num is 15. So I'm doing 15 iterations, right, of this loop. And then this is from 0 to column num, right, where I'm doing 20 iterations, so 20 columns for every row, which it looks like there is, but there's not that many, 0 to 15, right? So then how many of these do I have? If you want to count them as an example, then we can just do a cout. And this is just some troubleshooting because we're not quite right. Again, we want to kind of output like number of nodes when we generate them, and we're going to say that it is M underscore P grid, and size is what we want to kind of generate. We want to add this in to this, add the size. And let's see what that gives us. How many nodes? We should have 300. And we'll see why, if we have less, what that means. Okay? So again, let's run this one more time. And then we're going to put up a first version up online for ourselves here. But this gives us a basis for doing a lot of things. Remember, each of these nodes, I can know if I have line of sight. I can draw line of sight lines every frame to the player if I really want to, right? Okay, cool. So I did this. Init success. This is interesting. Number of nodes 300. Yay, that's right. That's what I would have expected. 300 nodes that we have here. I don't expect this though. That's wrong. And it says debug mode on, but I don't expect to have this many. I think we're kind of offset. I think we're kind of offset down and to the left. I think we're not showing everything, but my concern is the number of nodes that it's showing here. So it means that maybe what I've done is when I'm displaying the nodes, display grid, and I have this row and column. So for every row, we're starting here every row. So row 0, okay, we're starting off at row 0, and then we're having a column 0, so row, column 0. And then it says, okay, so we're starting off at rows. We have to troubleshoot this a little bit. So our grid, and the other thing we also have to troubleshoot is the position. This is also important because we're setting the transform position of the nodes. Here's our path nodes. We're saying that, let's check this first. So we're saying that the position is equal to the width of each of the nodes, right? So width is 40 multiplied by the column, all right? So that is a problem right there because width means we're going to go to the entire width and then multiply by the column. We don't want to go the entire width. The middle part is what we want. So we want width times 0.5. That's the first thing. So half the width, right, multiplied by the column number. That's the first one we want, okay? Why? Because I'm going to go 20 and then down 20. That's what I want. Okay? And let's see, maybe I'm wrong there, but that's one. The other thing is if I go half the height, right, for my position, right? Because remember, it's going to be the middles. I'm just calculating the middles of my position here, middle and middle. And if I was to do just this, what would it do? Would it make it tighter? Would it make it wider? You know, what does the effect of this do for us, right? This is something we can kind of align in terms of our grid spacing, right? So that makes it tighter, right? So this is what would be the way, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It should be 15. But actually, well, maybe it's 19, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And sorry, we said 19, right? 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, it should be 1 and 1. So what we can do is we can add additional 1. So 1, we want to do another iteration. So 0 to the path node plus 1. I could do that. So config plus 1, and that would give me 20 rows exactly. So I want 20 rows, right? 20 rows and 20 columns. That's what I want. But the problem is that we've got 300 nodes somehow, right? It's just the wrong shape. Unless I'm not showing something and something's not visible. Maybe I've got 300 because this says it generated 300, but it didn't do it right. So this is wrong. Obviously, this is I'm just showing you that it's like, you know, you can compress it. You can make it so it's half the width that I was showing you, or half the height. And this display also might be wrong, right? So remember, we're saying go to the grid, look at the 0th row, 0 times config column number, right? So column number would be 0, 1, 2, 3, and so on, all the way to 14, 0 to 14, right? So if I go 0 to 14, right, as an example, then if it's 0, then it's plus the column, whatever the column is. So 0, 0, that would be the first one, right? So I'm looking at 0, 0, get the transform position of that one, all right? And then what I want to do is I want to take that transform position and I want to subtract the same amount, so the row plus column, and I want to subtract half the width. And I'm going to do the same thing like I did before for half the height, half the width, and half the height. That's what I'm subtracting there, half the height and the width. So I march back because I'm centered, right? So I march back and I march back to the top because that's what's going to give me that centering, right? Because I want to position I don't want to start my counting on the top left corner. I want to start my counting in the middle. That's where I want my point to be. My point to be is going to be the middle of the grid, not the top left corner. The top left corner is actually wrong if I was to not do this, right? So that's what the display is. So the displaying is right? Here's another thing I could do, right? Instead of doing it, I could not do it this way and just basically print out all of them, as an example, every single one of them. But my problem is like by doing a for each loop equivalent or a for in, a ranged for loop. But the problem with that is I wouldn't get this information, row and column, right? I would miss this information, okay, which is what I need. So again, start off with row 0, that's the top row, and then I march along, I multiply that by the column number, right? So if the column number is 1, right? So multiply by row, multiplied by the column number. So if I say row is 0, then this is 0 plus column. If I say row is 1 multiplied by the column number, so by 20, that's what this would be, 20 plus the column, if they would start off at 21 and so on, right? And we could count this, that's another thing we could do, we could output this like so. We can say something like position, so standard cout, and we can say the position, and the grid position is what we want. Grid position. This is just troubleshooting, guys, and then I'll let you guys go. Would be this part, row, column, config, right? Okay, because that's the position, because that would be the position of the grid. So let's do this. When we display the grid and when we generate the grid, I want to see what the grid position is, because that is important. That is the grid position, the grid display position, right? And this is important, and that'll give us some output. And also, this is going to be output because this is going to be the row and column of where it gets added. 0, 1. It's going to march along the same way. So zeros, all the zeros, all the 1s, all the 2s, all the 3s, all the 4s, all the 5s. It's going to keep doing that over and over again until we have 300 nodes. So we can do the same thing here. So we're going to say grid position. Okay, so let's see what that looks like just from a debugging perspective. We'll take that away after. And I'm way over time, guys. I'm so sorry. Vinny, yes. I didn't exactly get the display. Yes, 19 by 14. Is it shifting left? I think so. All right. So it says that it's printing over and over again as an example because of my display position. Let's just undo that. Stop it. Yeah, I turned debug mode on. Let's try that again. When I turn debug mode on, it prints all of them at once. But what I should do is not turn debug mode on and see what happens first when I generate the grid. So this is interesting. So it says number of nodes 2. It went through. Let's see if it skips. What I'm looking for is skips, which is a bad thing. It shouldn't. 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. It keeps doing that all over. And I'm counting correctly. Look, it's counting right. 88, 89. What I was hoping to not see is any of these, like any kind of like skipping. So this looks good, right? All the way to 300, right? So my logic is sound. It goes through all the way to 299, right? So that's good. And then when I press H, right, it does the same thing. You can see that the display position also generates numbers from 0 all the way to 299. So that is also correct. So we actually loop through everything. So this isn't a problem. It's not my position being at. My build grid is working properly, so I can get rid of this. Right? We know this is happening, right? My grid is there. My display is not. My display is off, right? So I want to get the transform position. If I just left it at the transform position without moving it back, let's say, I'm not moving it back, you know, I don't accommodate for the width and height loss. Let's just take away this GLM vec2 by just commenting it out. So we'll say comment it out, and I just want to add this in there and then see how that works, right? Because it's just this, right? Display position, and I just don't put this in there. There we go. So I just want to comment that out. See what happens, right? Because at the end of the day, maybe it's something to do with the way I'm drawing. Remember, the drawing doesn't draw in the middle, doesn't draw centered, but it should draw 300 nodes, right? That's for sure. So what does it draw, right? That looks better, actually. That looks pretty good, right? So we just got to stop this. Let's try that again and get rid of this. We don't need this anymore. We know this is happening. We know the grid position is good, right? And let's try this again. So that actually looked good, that position. Better than actually that it was before. So let's see if I did it, if I had the right thinking but the wrong direction. So I've turned, it's on, it's good, but you see how this one is here at the corner, right? And let's count again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ah, that's good. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it needs to be shifted down and to the right, not up and to the left. That's what I was doing. I was doing up and to the left, but actually it needs to be shifted down and to the right. This is the top left corner of the grid. Look, it's the top left corner of the grid. I need to go down and to the right, not up and to the left. I was just going the wrong direction. So that's the answer. So I'm just going to put these back, right? And I'm going to move half a step. Instead of subtracting, I'm going to add half a step to the right, because this is the actual position. Remember, this is the printing of the position. It is not really that critical, right? But it's down and to the left. I'm actually adding half width and half height. Let's try that now. And that should be looking pretty good. Yeah. So let's try it again, and let's see that how it looks. Now it looks better. It looks good. It looks perfect. No, it doesn't. No, it does not. Even that's wrong. Okay, so let's take a look, because now we're too low. Look, we're here. We should be marching back a little bit more. So we went too far. Like, it's almost like this looks okay. This looks okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That looks good, actually. The width is good. The height marched down too much, I think. It should go back a step, right? Because you got to figure that these are all 20, 20 by 20. So these are 40, 40, 40, 40, all these positions, right? But they got to march back. They got to march back up half a step to there. So maybe we don't need to move it down. We just need to move it across. All right, let's try that. So the down part we can get rid of. So the height times 0.5. Let's just not even do this part. Let's just do 0. All right. And let's see what that does for us. Again, this is just playing around with the display numbers. We're not really influencing the actual position. The actual position is the top left corner of our grid, right? Yeah, still doesn't look right. Still doesn't look right. Something's off. There's a miscalculation I make. But again, you get the idea. The idea is that you've got a grid of tiles, right? And it should be actually slightly higher even than that. slightly higher than that, because you got to figure that it's 20. It's the grid should be. This is right because this is about. These are like 40 by 40 grid tiles, right? And this should be the exact middle of that 40 by 40. So it should be like, it should start here and go down to here, here, and here. And to show you this, what you could do, instead of making it 5 by 5, the right visualization would actually be to draw the tool again. So we'll draw both. We'll draw the middle, and we'll draw the width and the height, which will be like 40 by 40. Let's just make it 40 by 40. So we'll do both. We'll do two rectangles, one and then the other one. That'll help us visualize more, because that's important, right? I mean, 5 by 5, that's nice, but it's not exactly what we want. Let's try it again. I think that's the problem. Yeah, see, this is the thing. This is what we're visualizing. So see this? That's not right. It should be this part, this whole grid should be on the top left corner, right? So that is where it should be. So that's the actual grid, right? So I don't want to move it at all. So I want to just draw from the top left corner. So the position plus nothing. But that means that my actual position is the top left corner. That's what this means. So position is equal to, that's the this is my actual grid position, this part. But my physical transform position is wrong, right? Because this is saying, hey, get my width from my position and my height multiplied by the column. And this is where I want to move to the right, and I want to move down. My right and down is what I want to do here, right? And that's why we're having issues, because this position is actually top left corner. If I took away the position, look, if I take away all the position values, so I say, hey, let's take away the position values for all this stuff, right? So I don't even add any more GLM anything. I just like, let's take the actual position of the grid, right? So this is why I want to visualize this, because this is giving us the external grid size, right? There. So you see we're off. It starts here, right? And it shouldn't. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And these aren't wide enough, it looks like. Like they're not, and it's on my screen is 800 by 600, but I have, oh sorry, no, it's correct. I have a little bit of a title. The title is here. This is where the title bar is. So you can't count the title bar, right? So actually it's correct, but this is wrong, right? This is the top left position is where this is, right? That's the actual position of my object, right? But actually the actual position should be here. So it should be to the right and down. So let's adjust those first, and let's not print out these ones. I'm sorry guys, I know I'm taking long. I feel terrible. I don't like doing this kind of stuff, but you know, it's trial and error until you get stuff. So yeah, so this is my grid. Let's just draw this one first. So this is where it's the middle, but what I want to do is I want to go to the right and down. So that means I got to adjust this to the right and down. My actual position should be the center, right, to the right and down. Okay, that's where it should be. So path node, again, it should be for my position should be the column, and then I should add width. So to the right, so this is width, the actual column width, right? Times the column, but it's like I want to go to the middle. I want to march across half a width more, right? So width, whatever the width is, multiplied by 1.5, right? And I want to go to the height down. So I want to multiply that by 1.5. Let's see what that does for us. Because what that's doing is I'm adding half a width in position and half a width down. And then I can march back, because that's what I really want the width and height to be. And it should be offset accordingly. So that means that, yes, that's not what I wanted, but it's neat, but it's not what I wanted. Yeah, that's not what I wanted, because then it's multiplied by the height. So this itself is the width and the height. Sorry. So if the width is 40, that's the position, right? The x position. So x position is 40, right? Multiplied by the column, which is 0. So then it goes to the next column, 40, but it shouldn't. It should go, all right, so let's try it again. March it back. So if I did 0.5 and 0.5, sorry guys, this is where this stuff happens, where you have to kind of think things through. This is going to make it half the size again. And I know what this is happening because I'm multiplying it by column and I'm multiplying it by row. So what's happening is it's going to compress everything again, like so, right? So this is compressed, a compressed grid. We're making it smaller than the other one, right? So that's an issue. That's a definite issue, the way I'm encoding this part, right? So that's not what I want. It's definitely not what I want. I want to do 1.5, and I definitely don't want to do 0.5. Width and height is the top left corner of my game object. That's what it's going to do, the top left corner, right? But that's not the position. That is what it's reporting the position as. But I got to move across half a tile size. That's what I'm going to do. The tile size 0.5 more. Plus, I want to add half a tile size, not multiply. I want to take this out. Just math, right? So I want to say path node, right? And then what I want to do is I multiply these together, and I want to add half a tile size. So config tile size multiplied by 0.5. Let's see if that works a little better when I add it to the end. That's what I really want to do. Add a tile size. I just want to move this, just translate it down. And I know order of operations means these will work first, and then I'll add stuff, right? So this will be 0 at the beginning. So 0, this will make the 0 plus half a tile size. Yeah, it might work. Let's see. Sorry, order of operations in my head. Yes. No. No. Well, actually, hold on. If I don't count the thing, it went down to here. I'm offset by, again, it's kind of hard to see. Let's print out the same thing. Hold on a second here. Let's print out the same thing, but we're going to go march back. Because it's the right size. The size is correct. It's the position that's wrong, right? So, so this is the rectangle, but now I want to march back. I want to march back this rectangle by this. That's definitely what I do. I want to march this back. So let's march it back, and then print out the other one as well. So this, march it back. I'm marching this back to the edge, and then this will be the actual position at 5.5. All right, let's see if that works and what I get now. This is the display. This is the actual tile. Yeah, it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Almost. This position is right. The actual grid position looks okay, but this part right here, this part right here does not. Because look, I'm marching back again. Did I miss something? Yes, 0. I got to march this back too. I didn't march that back. So, column, row column height. I didn't do that because I took that away. Row column get height. One more time. With half an hour over. It takes time to do this stuff, guys. I'm going to tell you. And this is just like off the top of your head. Yes. That's it. That's what we want. So that gives you two things. That gives you the outer tile, which is the where the tile map would be. This is where you're going to place your map tiles. And this gives you the inner position. That's the actual, that little dot is the position of the center of the game of the tile, the path node, right? And then what you can do is you can calculate from the center to the player, right, every frame. So when I move the player around, and the player can move anywhere he wants, right? But right now he's moving across this row here. And the same thing goes with the enemy. The enemy would actually be centered instead of where he is right now, which is kind of in a cross. He'd be centered across one of these tiles, you know, kind of in this grid. Okay. And the next step for me would be to actually print out the line of sight lines. So display grid and display sight lines. One more time, guys. We're almost there. So again, we have a public display grid and void m underscore display line of sight. So we're saying the grid line of sight. Grid line of sight. Okay, so that's what I want to say. So line of sight to the player is what we're going to do, right? From each grid tile. Okay. Now the problem with this one is we don't have line of sight that we're calculating, so we're going to have to set line of sight for all of the grid positions every frame if we're going to do it that way. It's pretty it's pretty intensive. So if I'm going to do that, I'm going to have another method that's like set line of sight. Void m underscore set grid line of sight. All right, so each of the grid tiles is going to have line of sight. Let's generate this one too. And because we need this for assignment 4 anyway, right? So what this one will do, set grid line of sight, is it's going to do collision manager, collision manager, and then we're going to do line of sight check between the player and each of the grid tiles. So, well, sorry, the grid tiles from the grid tile to the player. So from the grid tile, and again, the grid tile that we're going to do is for each grid in the tile. So we're going to do a for each node in m underscore p grid, for each node auto, for each node in the grid, right? What I want to do is I want to check line of sight with the node transform position, right? Oops. And so that's the first thing. So the first thing is from and then to. And the to is to the player, m underscore p player. And I want to use the obstacle as the thing. So we only have one obstacle right now. We would have to do this within for all obstacles that we would have to do. We only have one of them. So you can see that what the challenges are going to be if we did this. M underscore p obstacle, right? So there's the obstacle. And why is this giving me an error? Cannot convert value L value vec2 to display object. Oh, sorry. Node. I'm doing too much work. So from the node, from each of the nodes, path node. Oh, see, now this is where, remember we said we may have to convert this path node to a display object because line of sight works with display objects, not with game objects. That's no problem. So if we're going to do this, we're going to go to path node, and change it from a game object to a display object. That's not what I wanted. But whatever. I'll do what I have to do to make this work today. And then we'll rejig it later. Maybe we want to make line of sight with game objects, not display objects, which would work too. So for now, I'm just going to make it work. Remember, make it work and then fix it later. All right, so now that should work. Good. So for every node, I want to check. I'm going to draw a line between the node and the player, and we're going to say that this returns Boolean. So we're going to say the node. We're going to store this node, and then we're going to say set line of sight to be true or false, right? True or false. Set line of sight to be true or false with the player and the node. What does this give me? Why does this give me an error? clang auto tidy fix auto star. Isn't that funny that it did that? That's new. But auto should work too. Auto is perfectly fine. Yeah, so what this is saying is set the line of sight. So I know that each of the nodes has line of sight. Set grid line of sight. Is it true or false? Right? And only for those that have, we can actually show the grid. So this is set grid line of sight. Now we can display it. So we can say that for each of those nodes, right, we have line of sight, and now we want to draw the line of sight with a draw line, which is the same draw line that we used for the first one, which is this one. Okay. So draw line of sight. So set display grid line of sight. We want to do the same thing where we say we want to draw a line from the node position, to the player m underscore p player position. That's all I want to do. I want to draw this when we want to. And you know what? We also have an option to change the color, where the it's a vec4 color, and it's 01, so RGB1. I want to make it so it's a new GLM vec4, where I want to generate R red, green, blue 1. So I'm making big blue lines for the nodes, so we can make a difference between the nodes that have line of sight as well as these other ones. Okay, and we want to display our line of sight inside of the display grid line of sight when I turn that on. Just for now, we can also not do that. I'm just generating it. But we also have to, in the update, we also have to generate, do we have line of sight or not? We want to keep track of that. So we're going to say that m underscore, we want to do line of sight for it. So set line of sight for the grid. I want to do that every frame, because if we don't do it every frame, then we'll lose line of sight tracking for everything, right? That's what this does. And in order for us to do that, because we're doing from the grid to the player, in order for us to track that, to return positive yes, one thing we have to do is change our collision manager a little bit, right? Because we do the update here, go to definition. And right now the line of sight check, it doesn't really care what it's colliding with between the two objects, and that makes sense. Actually, we don't have to change anything. So it looks like that would be okay. But there's no line, there's definitely, it's going to return false or true, depending on what the situation is. Let's try this out and see how it's crazy. If it even can work with all these 40 different things attaching to the player. It'll be like a bunch of lines attaching to the player at once in our debug view. And we can also say that if it doesn't have line of sight, it's red. We can change the sight lines so that they're red. If they don't have line of sight, into green. If they have line of sight, we can do all kinds of stuff. Wonderful things with debug. Right now I'm not going to do that because I've really run out of time here, and I've spent a lot of your time doing that. So you can see that that's what it works like. So each of the grid lines shows line of sight. If I move the player, you can see that the line of sight will change depending on which of the grid items have that player. I don't know if that makes sense, but that's how it would work, right? So you can see that each one of these these nodes are producing line of sight lines with the player, each one of them, right? And which is what you want. You want to see that this is happening, right? One thing that's being lost though is the grid lines, the line of sight lines with the from the enemy to the player, right? But these are interesting. And what you may want to do is again, there's a lot of nodes, right? We could cut half of these nodes down by making much bigger grids, like much bigger ones. Like instead of making a 40 by 20 grid with a backdrop, we can make them so that they're bigger, like 80 by 80 or something crazy like that. Because you can see that there's an even amount, right, for how many there are. So that's one thing we can do. We can also make these lines less apparent. So, example would be with our grid lines when we display the grids. So again, I'm going to do the same thing with, instead of the collision manager, let's get out of here. Let's go into the play scene, and when we, down here, when we display, the grid is okay. Display line of sight though, this is like for every item. And what we can also do is we can specify that the transparency is like 0.5, because you can put in whatever item you want in here. So we're going to say it's semi-transparent, so it's not as crazy. We can see everything this way. Let's try that out. And we can also check to see for each node if the color will change. So we can say like auto color, that's going to be equal to, depending on if the node has line of sight or not, right? So like I said, we can take this part and do this, and if the color is this, but if depending if it has line of sight, then the color is something else. We can say like if the node dot get line of sight, if line of sight is true, if it's positive, then we want to make this color equal to this this blue color, or however, if it's positive, we want to make it red. If it's negative, we want to make it blue, right? So we're going to say it doesn't have any line of sight, or so do I have line of sight? If I do, it's blue, right? And we can make it even like fainter, like something like 0.2. As an example. But if it doesn't have line of sight, then we can make it red, and it'll be 1. So red and 1, and this would be RGB, so we make it red first, and this would be 0, right? So we can make it red, so color, and then we can pass that color on to the draw line. Instead of doing this, we can say, hey, give me my color, whatever that color is going to be for the display. So that might make it more palatable for me to do that. Maybe it'll make it worse. I don't know. Let's see. But we should be able to calculate if it has line of sight or not based on color, and that's something that we can do with our other lines too, because it makes sense to do that kind of stuff. So you can see that these don't have any line of sight, the red ones, as an example. But as I move to this one, you can see that the line of sight changes. These are all, the red ones don't have line of sight, as an example. But these ones all do have line of sight, these ones, the blue ones. So what you could also do is only display the ones that don't have line of sight to the character. So these ones all are blocked, as an example, for this particular obstacle, which is kind of neat, right? Vineet, you had a hand. Looks cool. Yeah. Yeah. It can. There's a lot of information here going on, right? That's why, we got to limit some of this. We got to cut this down because even the the alpha transparency doesn't seem to work for this thing. So the only one we want to do is if it has line of sight. So we can do that. We can say that. So instead of doing this thing, we just set the color to the same. We don't care about the other ones. So say if node get line of sight. If it doesn't have line of sight, like this, that's another way to do it. If it doesn't have line of sight, then only show the ones that don't have line of sight. Don't show me all the ones, because we don't care about everyone. We only care about some of them. So, and then we can go back to single color. We can say that the node is going to be blue or red or whatever we want to make it. We'll make it blue. Because blue is different than green. Red is a little bit too stark, I think, right? Because too crazy. You can change the colors here. You can make it. You can experiment, and to make it so that it's a nicer color than what we're doing here, right? But again, it's just a debug view, so that way you can see the line of sight, sight lines, right? Now it's not required in the assignment, but again, we could do it, right? We could do it. When we were making the assignment, Alex said, "No, you don't want to show all those," right? But you can see that these are all the nodes here now that do not have line of sight. All of these ones, right? And it really depends on where it's working. So these are all the nodes. And then you could say the closest nodes are the ones you care about. This one, this one, this one, this one, this one, and this one, right? So you can choose some of the nodes, but not all of the nodes. All of these ones are too far away. So these ones will be the ones that are the closest. And these ones don't have line of sight either, right? These ones in here, right? Okay. Neat. So that's kind of a debug view for you. And if you had more than one obstacle, you would cycle through each of the obstacles too. So to give you some idea of what the debug views would be, you can even have another debug key inside the debug to turn off. When debug mode is on, if I press this key, then show me the sight lines. That would be something. And you can also say, well, I don't want to display the grid line of sight. Maybe I want to just turn that on when I'm debugging by hand, right? Because I can do it, but I don't need to do it. And all I really need is to know the grid lines, which is kind of what I asked for, right? But this would suffice. If you did this much, then now you have 3 out of the 4 things that I've asked for my debug view. And you've already set up your grid in order for you to do that, right? You have this part. So you can see that there's a sight line between here and there. And instead of us doing output here, we can make this line red or green, depending on if it has line of sight, which I just showed you how to do. All right, guys, this is enough for today. I think we've covered a little bit more about setting stuff up. Let's put this up on GitHub. This will be our final commit. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say Added Path Nodes, which is what I've really done. All right, so commit all, Home, Sync, and Push. And that should be it for today. Yeah, and I'm so sorry it took a long time. It took an extra 45 minutes, but I'm really happy that you guys stuck around. I think it's great. Again, guys, for the people who are doing this, what I would require is as much as you can from what we did today. I think that's the best. I think the minimum would be at least getting to the point before we start doing the path node, so which is what everyone else did in the first section. All right, great. I'm happy you guys had a good time. Thank you so much. I'm going to stop recording now and enjoy your weekend. And I'll see you guys next week. Good luck on starting your assignment. So I'm stopping.